All right, this is just determining whether a relation is a function given a set of points or a graph. This is kind of important. It's a pretty easy skill to master, okay? Neve, all we're looking at really is the inputs, the x values, okay? Did you forget your notes? Do you need a copy? Okay. So we're just going to look at these. So do you see how the 2 repeats right here, Neve? Not a function. It's not a function because that 2 repeats, right? We learned that. Jack, you okay with that? Now here, is this a function? So we're only looking at the inputs.
Yes.
All right. Very easy, correct? Jack, what would you say for this one right here? Function or not a function?
Function.
Function. Nate, what would you say for the next one? Not a function. Why? Yeah, this and this. I'm not going through all of these problems just because there's a lot of them. I put a lot of them in here so I can pick and choose which ones. All right, if we look at number 4 real quick, okay, this would not be a function because notice, see the mapping? The mapping can get confusing, but you're really paying attention to the arrows in the mapping. Andrew, do you see how there's 1/2 and there's 3 arrows coming from 1/2? That means it's being repeated. So number 4 would be not a function. Easy enough, right? Nick, what's that? Yeah. No, let me check. All right, so this is going to be the vertical line test. Notice, I just have the vertical line, Harshan. You see it?
Yes.
How I have this vertical line?
Mm-hmm.
And all I'm going to do, Harshan, is just drag it across my graph. So when I drag it across my graph, notice it's a function, 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 function. And then hold up right here. Do you know why I'm stopping right here, Harshan?
Because you're on the y-axis.
I am. But do you see how I have 2 closed circles here? Closed circles mean I'm including that point. So this is not a function because it touches that point and that point at the same time. Okay? But over here, all right, if we drag this across, now this isn't a function because of this, but that's not the point I want to talk about. I want to talk about these. So here you have to pay attention to the circles. Do you see how that's open, closed, and open? Okay, things like that can happen. And if it's an open circle and a closed circle, well, then it could be a function, okay? Take my straight line with me. Obviously, you can see all of these things, whether they're a function or not, pretty easily. All right, so I'm not going to go over these, but I do want to review domain and range. So this is page 7. Okay? Now, here on page 7, my domain, all right, and I use D for domain. Okay, it's continuous in this section because it's not a bunch of points. So it's kind of like X in the middle. Now here, this goes up, and this comes down, and it's going to be, let's see, -2 is less than or equal to X, which is less than or equal to 3. Got that? My range, I'm going to go the other way with it. I'm going to go with the lowest point and the highest point. So my Y value has to be between -1 and 2. All right. Now, with a question like B, we haven't seen one like this before. Correct, Emma?
Yeah, kind of.
It kind of looks like A, but it kind of doesn't. Now, with questions like B, well, I kind of have 2 parts. Okay? I have this part, and I have this part. Well, let me put that in a different color. I have the green part, and I have the blue part. So let's look at the green part first. The domain of that, okay? Notice I drop that down. And this arrow at the end, I want you to pay attention to that arrow. That means it keeps on going. So for the green part, X is simply going to be less than or equal to, because it's a closed circle, 1. And then we're going to say, or. Now for the blue part, and here's where it gets tricky. I drop this down, okay? And that number's 2, but notice it's an open circle. Do you see that? Open circle? So it's going to be just less than X. So I have X is either less than or equal to 1, or X is greater than 2, okay? And if you're really struggling with that, Neve, what you could say is X is anything but numbers between like 1 and 2. Do you know what I'm saying? Like you want to use your words and best describe it to the best of your ability, okay? All right, so if you can't remember notation like this when you're like working through it, write down what you know and be like, I don't know how to write this, but basically it's going to be any number but numbers between 1 and 2. All right, now for your range, okay, your range, again, we're going to have 2 parts. We have this black part, okay, that, all right, again, we have the arrow coming into play. So it's going to say Y is less than or equal to 1, or, now I have to address this part. The arrow is going to come into play again here, or trace that over, that's going to be 3, so 3 is less than 1. All right. And like I said, Jack, I don't want to go over every problem, but I wanted to go over some of these just to kind of refresh your memory. All right, and now we're going to skip all the way to page 9 where it says lesson post-test. And we're going to do this together. Because this is kind of what you guys just did. All right, let's go with Sophie. You there?
Yeah, I'm here.
What's that?
I'm here.
All right. Sophie, question number 1 asks, which graph shows y as a function of x? So which one of those graphs is a function?
That means that the line like doesn't intercept 2 points on the.
Very good.
Is it A?
Okay. So let's start with which one is it not? Can you hear me?
Yeah, I can.
All right. Which one is it not?
Wait, if it's a function, that means the line doesn't touch twice on the graph.
Correct. It can't touch twice. So let's eliminate which ones it does touch twice on.
It doesn't. It touches on C twice.
C. So we can eliminate C. Now, what's giving you problems about A and B?
It's B.
It's B? Okay, why are you saying it's B now?
I don't know.
No, it's okay. We're having a good discussion here. So why are you saying B, or why is this getting tricky?
Well, because B has like an open circle, so I don't know what that means.
Very good. All right, so let's look at A. So I'm going to zoom in on A, okay? We already eliminated C, so let's look at A. What does a closed circle mean? Does it mean we include the point or not include the point?
You do include the point.
Okay, so if I draw a vertical line and I'm including this point and this point, doesn't my graph in A touch at those 2 points now?
Yeah.
So then my answer is not A, and it has to be B. And that's going back to what I was saying. You have to pay attention to open and closed circles. All right, let's talk about number 2. Number 2, this is Potts. Who am I picking on? Mackenzie.
Yeah.
Which one of those values, -4, -2, 4, or 8, is not in my range? Do you have any idea?
-2.
Okay, let's look at it. So here's how you determine if something's in your range. First off, I'm going to highlight each of these numbers on my y-axis. So there's -4, right? Here's -2, here's 4, and here's 8. And here's what I'm going to do. Ready, Mackenzie? I am going to trace that number over and see if it touches my graph. So let's start with -4. Does -4 touch my graph?
Yeah.
Yep. Okay, so that's part of my range. Does -2 touch my graph?
Yeah.
What's that?
Yeah.
Okay, so that's part of my range. Let's go to 4. Does 4 touch my graph?
No.
No. So that one is going to be the one that's not part of my range because it's not touching my graph at any point. Jack, you okay, buddy? Look like you're deep in thought. All right. Now, here's what I want you to do, okay? I want you guys to answer this constructed response question, meaning open-ended question, on your own. And I'm going to give you a good bit of time. I'm going to give you like 5 minutes, okay? Now, let's see. Nate, how can I have you do this? I got this. I think I know what I'm gonna do. You want to try on the board? So you don't have to write it down? If you don't want to, you don't have to. See how it is. Think about it. I'll tell you how to do it. But this is how this stuff's going to be presented on the keystone. So I can get a little warmer in here.
Yes, it is. Oh. Mhm.
Really.
Yeah, from the hip up.
Ours was from some of all the chemicals. Just like washing your hands and everything like that. Just like, my hands used to be all Feel the breath. Yep. Don't forget B and C on the next page.
I'm afraid more snow.
Is it?
It's more cloud.
I mean, I hope that it's, there is moisture up there.
You know, we could have early dismissal days.
I think that's more of a household, just calling it something. Because you
Remember the days we got stuck?
see that, I think,
Buses are here, so now we do it like an hour.
yeah, the benefit of being a Penrose, it's gotta have something. Best part about being a Penrose is like your school day is done so early, and like you have the rest of the day to do it up. Like, Nate's gonna make it come to watch the Steelers game tonight. Got to root for some good, PA team.
Somebody's got to be good.
It's not the. We got a lot to fill. So. All right, let's start to look at this. It says plot the relationship on the coordinate plane. Label the graph including dependent and independent variables. So a scientist is observing bacteria found in the following relationship between the number of hours and incubation and the number of bacteria colonies. So first things first, I know you asked this, so I'm going to address it. Time is typically on your x-axis, always, okay? I'm sure there's a case where it's not, but when in doubt, time it out. So this is going to be hours And this is going to be, I'm going to put, what? Bacteria. Okay. So now all I'm going to do is I'm just going to plot these. So I saw Harshan doing this, right? So it's going to be, well, first I got to figure out what each block is counting by, right? See how they're counting by 10? So 2, 4, 6, 8, 10, right? They're counting by twos. So 2 and then 5. Well, where is 5? That's like going to be halfway between two blocks. So right about there. 4 and 10. Right about there. 8 and 20. 8 and 20. 12 and 30. 24 and 60. All right. Do we see that? What does the data look like it's doing, Maya? Maya, what does the data look like it's doing? All right. Hope, what does the data look like it's doing?
It looks like, wait, what was the question?
What does the like points look like they're doing?
Like, they're like, kind of like diagonal, I guess.
Yep. Are they going up or down?
Up.
Up. So if they're going up, I know that the longer they sit around and incubate, the more colonies I get. Now let's go look at the next question. It says, is the relationship that the researchers found a function? What do you think? Hope, yes or no?
I think it's a function.
What's up, dude? First period. Thanks, Chris. So yes, it is a function because it passes the vertical line test. That's it. Easy enough. Now describe the domain and range. So the domain would have been what? My H values, right? So Jack, what were those H values? So domain was 2, 4, 8, and wasn't there a 12 in there? And 24, okay. And what was the range? Range, 5, 10, 20, what was it? 30, 60. Show and explain your work. Well, that's easy. Domain is your time values, and the range is your bacteria colonies. That's all you got to do. See how easy these are? Pretty easy. How do you feel about them? Pretty good? Pretty good? All right. Delete these. All right. Last question of the day. A new store opened and the manager recorded the number of customers in the store each during the first 30 days the store was open. The graph below represents the results. Kind of weird, right? Okay. So is the relationship that the manager recorded a function? Yay or nay? Who's at home? No. Drew. Drew, yay or nay? Function? Drew,
Yes, I think it is.
it is a function. Why?
Because when the points are on the same line, one of them is open.
Very good. Yes, because it passes the vertical line test. And this is what Drew is talking about. If I draw my vertical line and I drag it across, notice we're only touching the black graph at one point. Okay, here, only touching at one point. Now here is where he said, well, this is okay because one is closed and one is open. Likewise here, one is closed and one is open. What is the domain and range of the function? Well, that's interesting, right? So let's look at the domain. The domain is what?
The x values?
It is the x values. But wouldn't it be like essentially 0 through 30? Because it's talking about the days that it was open. So I know this graph looks confusing, but in the problem it says 30 days that it was open. So the domain would be 0 to 30. Okay? And then if it lasted after that, okay, if the store didn't close in the first 30 days, well then you could write as long as x is greater than 0. Now what is the range? Well, let's think about this. Well, in the first 5 days, we went from 0 customers, or 0, like in 100, to 500 customers. Then on day 6, it jumped up. Maybe they were running a promotion to 800 customers, all the way up to, what is that? About 1,800 customers. Then the novelty of the store being new wore off. So it dropped back down, right? And then it jumped back up because they were running another sale, or maybe it was Black Friday. So what you would want to write is something along the lines of 0, y is between 0 and 500. Then it's between 800 and infinity. Yeah. All right. That's it for today. Okay, no homework tonight.